All right, I think we can kick things off. Thank you everyone for joining today in our webinar of what to do when you're drowning in data. I'm Eric, I'm one of the co-founders and CEO of Encord. I'm joined here today by Nico, our product lead, who spent a lot of time thinking about how to curate your data at scale. So I'm very excited to hear what he has to say later in the webinar. But first, a quick agenda for the talk today. So we'll start with a quick introduction on our side, explain what Encord is, why we're talking about this topic in the first place. Then we'll go over quick AI preliminaries for everyone, and then why data curation matters. So some people think that data quality and curation might not matter. It's all about data quantity. Hopefully by the end of the webinar, you'll hear a good argument for why we think curation actually is quite important and quality really does matter. And finally, we'll go over how to actually curate your data at scale, which will include a live demo of doing this in a real world system. So without further ado, we can kick things off. Maybe first, a little introduction on Encord, what we are. So if we go to the next slide. So Encord is a data development platform. We help AI teams automate their data lifecycle in a single workflow. That includes three core components. The first is curating your data at scale. That's the topic for the conversation today. The second is managing human workflows. So that includes annotation, validation, preference ranking. So anywhere where human judgment is involved. And the third is model evaluation. So making sure that your models are continuously getting the right data and taking the wrong data out. And all of these are in one core platform, which we work with in an automated workflow with a bunch of AI teams, some of the most sophisticated in the world. So quick aside, there's some new stuff at Encord. So last week, we announced our $30 million Series B. We're very excited about it because we're going to use it to really double down on product and innovation. And it's one of the reasons why we also publicly released Encord Index, which is a system to manage and curate data at scale, and which we'll touch upon a little bit later in the conversation today as well. But enough about us, let's get into AI. So there are really three core components of an AI system. The first are the models. So this is the algorithms that process information, make decisions. You can think of this as the brain of AI. The second is compute. So the hardware and resources that train the models, run the calculations, do the data processing. You can think of this as the food that the AI eats. And the third is the data. So this is the information that specifies tasks and with which AI learns. You can think of this as the books that an AI system reads. So you have a model with a brain, it eats some food, is powered by the food, and it learns from books. So three core components. Now, with models and compute, we've seen tremendous progress in the last 5 to 10 years. So it used to be when you're building a model, you'd have to build it in C++. There weren't good libraries to do this. You would do everything from scratch. It was quite a difficult, onerous process. Now you can essentially run an API from OpenAI or Anthropic. You can pull an open source architecture off the shelf. You can train and run a model quite easily. And similarly with compute, with a single line of code, you can launch an instance and start training and running models from cloud providers. So these, most model and compute pillars have made tremendous progress, but data is still in its very early days. The tools and best practices aren't there yet. And it's really unfortunate because data, unlike models and compute, really can be an organization's competitive advantage. If you think about it, data is the one thing that is really unique to your organization. No one else has your data, whereas models and compute are becoming more and more commoditized over time. So data is the way that you can actually build a moat in your AI system. And arguably, data is actually the most important component in the accuracy and performance of an AI system compared to model compute. And there's plenty of literature that supports this view. So some of my favorite papers are papers like the Textbooks Are All You Need paper, where they showed that they could train an LLM just using textbook quality data, and it performed as well as LLMs that were trained on the entire internet. So orders of magnitude more data. So if you just curate the best data, you can actually get state-of-the-art performance, and you can train the model in a few days rather than a few weeks, fraction of the cost, much better overall. Another paper which I found was quite interesting was from Meta about automatic data curation. So with a clever data curation algorithm, what they showed was just by selecting data in a slightly better way, they could drastically improve the performance of a model. So this is not affecting the architecture, it's not affecting the parameters, it's really just selecting the right data. So the right data does matter, and we've seen that in the literature. We've also seen it from practitioners. So I usually don't like reading quotes from slides, but I think this is an interesting one. So this is from the CEO of Cohere. And he says, the importance of data, I underrated it dramatically. I thought it was just scale, but a lot of proof points have happened internally at Cohere that have just totally transformed my understanding of what matters in building this technology. A single bad example amongst billions. It's so sensitive. It is a bit surreal how sensitive the models are to their data. Everyone underrates it. So even though people know intuitively that their data really, really matters, they still underrate it. And this is from someone that's building state-of-the-art models. So data is probably even more important than you think. So why haven't we built great data systems? Why is data behind model and compute? You can see that with one piece of bad data among billions, you have a bad model. And with a bad model, you can make very, very embarrassing mistakes, even for the most sophisticated tech companies. These are companies like Google and Amazon and Microsoft. A model that's performing badly, it will make for a very bad demo. It will affect the stock price of the company. These, again, are the players at the very forefront. They are the most sophisticated, smartest players in the space, and they still make these mistakes. And they don't have all the control over the data that they should be. So why is this? Well, data systems fall under what I like to call the chicken sandwich problem. Okay, so there's a YouTube channel. It's called How to Make Everything. And one of the videos, the creator of the channel, he decided to make a chicken sandwich completely from scratch. So he made his own garden, he cultivated his own lettuce, his own tomatoes, he pulled salt from ocean water, he milked a cow for his own cheese, he did all the chicken stuff. You kind of get my drift. And it took him 6 months and $1,500. And when he actually tried the sandwich, he said it tasted not bad. It was okay. The sandwich is okay. Now, if I want to get a chicken sandwich, I'll probably go to the store, I'll spend a few dollars, and I will get most likely a better quality chicken sandwich than what this guy spent 6 months and $1,500 to do. So it would be pretty crazy for me to think that the best way to make a chicken sandwich is for me to go and create it from scratch. And yet, if you talk to a lot of companies, this is how they treat their data systems. They'll go and try to build internal data systems from scratch. They'll make huge kind of messy contraptions of these data systems. They'll spend a lot of time doing it. They'll spend a lot of money doing it, and it will just be okay. They don't think about buying the chicken sandwich. They always think about making the chicken sandwich. And preferably, I like my chicken sandwiches from the store. So the reason why it's important that you get the right chicken sandwich here is because there's a few reasons, but one of the key ones is about scale. So building a data system, it really has to scale. And you might think that this doesn't matter for an internal organization compared to something like OpenAI, which trains over the entire internet, but it actually matters quite a bit. So the amount of data that's in internal organizations is actually much larger than the data that's out in the public. So JP Morgan, just by itself, has 500 petabytes of data. This is essentially larger than the Internet Archive. So you really have to be able to create a data system that can scale with depth, but also scale in terms of modalities and types, because AI is constantly evolving, and you want to be able to keep up with all the multimodal innovations that are going on. And what we find is that people build internal data systems for one type of data, and it becomes very, very difficult to scale horizontally, much less in terms of the pure amount of size that a very strong model would require. All right, so scale. You have a scale chicken sandwich problem. The other bit, which a lot of people underrate, is that AI is a team sport. It requires a lot of collaboration. These are the most sophisticated systems that we've created. It requires data ops engineers. It requires ML engineers. It requires the the work of product managers, and they all have to collaborate with each other. And what we find is that people that make their own internal systems, they often build it with scripts that are in silos, and it makes it very difficult to share things across different stakeholders. And even worse, we find time and time again that people build a lot of redundant systems. So one group will build a thing that looks a lot like another group because they're not really sharing the information, they're not sharing the knowledge, they're not sharing the know-how. And so there's a lot of wastage within these organizations. So really, this chicken sandwich problem is holding back a lot of the data systems, a lot of the data progress that these internal organizations should be making. All right, so what do we do? How do we actually solve this problem? And how do we turn unstructured data to AI at scale? How do we really think about building a curation framework from first principles that will work multimodally, that will work at scale, and that will overcome this chicken sandwich problem? And for that, I will pass it over to Nico to go over some of the things that he's been working on and go over a live demo as well. So over to you, Nico.
Thank you, Eric, and thank you for the introduction on AI and the problems that we're solving here at Encord. Hey everyone, I'm Nico, product lead at Encord. Been building Encord Index with the team over the past 6 months, and I'm very excited to be here today to tell you more about the product and give you a little tour at the end. If you have any questions along the way, both some of the things we're going to cover now or some of the things that Eric mentioned before, please do feel free to share them in the webinar chat, and we'll get to them in the Q&A at the end. So as Eric alluded to, we're very excited to announce the launch of Encord Index officially. This is the newest product in our data development platform, and it's built as the world's first multimodal data management and curation product that's built for scale. It's built to support all file modalities, so from image, video, medical imaging, geospatial, documents, electrodiagrams, to audio and text. Alongside your files, you can import and manage your metadata, helping you to structure your files by capture date, location, manufacturer, and more. With our own pre-computed embeddings, you can search your data easily, and if you have a more complicated use case or domain, we allow you to import your own model embeddings. Everything is, of course, stored with the highest safety and security protocols, and you have role-based access control to ensure that only the right people have access to view or edit the data that they need to use. But first, let's put things into perspective. Here in this chart, you see what an AI data pipeline used to look like many years ago. Data collection, storage, annotation, some model training, model evaluation, and lastly, deployment. Back then, AI projects were often niche. They were undertaken by a single data scientist, researchers, or ML engineers, and maybe a small team. The data scientist was responsible for all of these steps, handling the data, making the annotations, training the model, and lastly, deployment. So very similar to the chicken sandwich that Eric here alluded to before, a single person had to undertake all of these different items at the same time. In the early days, requirements were low, volumes were small, and model capabilities were limited. But if we fast forward to today, AI projects has increased drastically in scope, and AI has rose in popularity at the same time. So more and more stakeholders are now getting involved. It's not only the data science teams, but also data ops, ML ops, and often multiple layers of management that are involved in these processes. This new complexity, combined with increases in ambition and project scope, brought with it the need for a lot of new tools. So a lot of new ingredients is here for our sandwich, as you can see here on the screen. Tying it back, we now have a full team that are going to be working on data management and cleaning. We're going to have a team that's going to be annotating and maybe versioning your data sets, and another team doing model training and model evaluation. At Encord, we're trying to consolidate all of these tools into one platform. And this is what we call the Encord AI Data Development Platform. Today, we'll take a look at this left-hand side, Encord Index. But as Eric mentioned in the beginning, we also have Encord Annotate to help you annotate at scale and automate it, and Encord Active to help you monitor, debug, and evaluate your models. First, a quick introduction to Encord Index before we dive into the demo. So what we see here is on the left side, all of the entities that we can ingest into Encord. And on the right side, we see a small preview of what we're going to look at in a minute. So first you ingest all of your raw data files from your cloud storage of choice, whereafter you can attach your metadata. This can either be in a local Postgres database you have it, or spreadsheets, or different JSONs here around. If you have any custom embeddings in a vector database or locally, you can import these as well to help search and sort your data. Now, let's dive into the demo. I'm going to switch tab here. And we're going to imagine a little scenario here today. So now within the Encord platform, and we can see here a explored grid with 30.8 million images that we've collected and imported into Encord. Today's scenario, we're working as an AI engineer for a conservation NGO, looking to build better object detection models for underwater conservation. Our team in the field has collected millions of images from diverse locations all across the world. And our job as the AI engineer here is to make sense of it. We want to catalog all of the different underwater species and their population. We have a lot of unstructured data with some semi-precise metadata. And we now want to gather these insights to help us build better models and save and conserve endangered species. Funnily enough, I was actually a part of a similar data collection project many years ago with an NGO in Cambodia, collecting images and metadata of seahorses in the South China Sea. So this is a real problem that a lot of people are trying to solve out there. So firstly, we've collected all of our data into our S3 bucket, as shown before, imported into Encord, and imported the metadata that came with it. So we just try and open up a file here. You see an example that this manta ray has metadata on its depth it was captured, what species it is, the location, and when it was captured. Go back here. As you see here on the right, we have collected a total of 30.8 million frames, way too much for anyone to go through manually at any type of scale. And this is also a scale that we cannot work with in a notebook or any of the open source tools out there that can handle maybe a few hundred thousands, maybe a million files at a time. With Index, we can now slice and filter this data down using a variety of different filters. So first, I'm going to take a look at my location filter and my species filter. This is related to the metadata we saw before. If we look at the list of filters, you can see here that you can filter on almost everything related to the data. So what integration was used, what folder it was from, the data type, and so on. So firstly, we'll try and slice our data on the location. So let's find images from the Maldives. And secondly, we'll try and go into the species. Let's go for jellyfish in this case. So what this does is that it now lists all of the images that contain these particular metadata fields on them and allows you to look at them, visualize them, and then catalog them in a second. One thing that came up as a concern while I was working on this from one of the other team members is that they said that there might be a lot of noise in this data. So the team member created a little preset for me. So preset is a set of filters similar to the ones we built now. And this preset was something that he mentioned was of very high concern. He said there was a lot of duplicates in this part that he found. So he looked at fish at the Great Barrier Reef between 10 to 12 meters from the period of March to May. Very detailed, that he managed to go all the way into that particular area. And what he said was there's duplicates. This is a natural problem that a lot of teams are facing, where multiple of the same type of images are imported into the S3 bucket. In this case, we can see a few examples here. These can now be selected. So we, of course, only want to have one unique file for each image. Let's go a little bit down. See, there's no duplicate here and here. And we can now add these to a collection. So this is a container of images that we can do something with afterwards. So we're now cataloging our data. We're going to call this duplicates, fish, remove later. So this now creates this container of images that we can reference later and catalog. If we now look at this particular image here, this particular set of images, we can see that our distribution of depth is fairly normal across all of the different depths, but there might be certain areas where we have issues with this depth one. So what we're going to do now is we're going to try and find certain species at different types of depth. So now trying to change this around to a different species. Let's move some of our filters. I want to try and look for, let's try turtle, and see turtles at this high depth at the Great Barrier Reef. Because if we have one type of noise in our data, this was duplicates, there might also be other types of issues in our data. I'm trying to remove our Great Barrier Reef in this case. While we are waiting for the search, here we are. Yes. So here we see turtles. And it's clear to me that there are certain images here that are not necessarily turtles we want to use for our object detection model. And we can also see that we have noise in our metadata. So you see how the depth here is measured at 10 or 11 meters, but these are clearly at sea level, at 0. So we now want to select these particular turtles and add them to another collection they want to investigate later to figure out this issue with the noise in our metadata. Call it noisy metadata. Good. Then our colleague from the AI team, he told us that he imported various different types of custom embeddings for a random subset of this 30 million data set and asked us to see if we could find any subsets to get our model training going for lobsters. So I'm now going to click on my filters for custom embeddings. We're going to take the ciclip model to begin with and click true. So this shows us all of the files that have a custom embedding of the type ciclip. You see we've trained 3 embedding models, the ResNet and the Clip32. With these embeddings, we get access to something called similarity search, where we can take an image and find similar images within the given dataset. So a very quick way to mine similar images that we might send for labeling, model training, or might use to catalog all of our data. But our team member here, he asked us to take a look at the lobster category specifically. So now let's go to our embeddings plot view, where we can see a 2D representation of these model embeddings. What we see here is that we can hover over given areas and get a preview of the images, so we can see how our data is nicely clustered by the model, helping us catalog and understand it. We can take a collection for this lobster class and see how the lobsters particularly are cataloged here. We see there are a few outliers, but otherwise it is neatly clustered in a little round area here. And we can now hover over these outliers to get a preview. So this actually look like we have images that are wrongly categorized as lobsters. So again, back to this noisy problem, we want to clean our data before we send it for labeling, so we want to structure it. Now we can quickly remove these. I'm going to add a filter for this lobster species that we have. Search here, lobster. Now we're only seeing the embeddings for the lobsters. And then we're finding these fish and sea turtles. Fetching them again. And we're just going to add them directly to a collection and call them wrong metadata class. So again, something for later that we can dig into with the team. Can remove our filters. The next part that he asked us for is we want to figure out which embedding model is best going forward, when we need to retrain and when we need to add embeddings to the rest of our 30 million dataset. We can now compare our embedding models one by one. So say we want to see how Clip performs on the lobsters. We see it's a little bit more all over the place compared to the other one. We can try and see how it performs on clams. Once again, there's not the best grouping. It's a little bit better here in the ciclip. And then lastly, we can take our jellyfish. That's really good here in the ciclip. A little bit worse on the clip. So my recommendation for my team would be, if the cost and the time spent that the ciclip is extra on top of the clip, if that's okay with us, then we should use the ciclip model going forward to compute our embeddings. So we've looked at a bunch of different things now. We've learned how to identify different issues with the data governance and the noise in our data. We've looked at how one type of clustering model can be better than the other one on this given data set. And we found out that there's a lot of noisy classes within the data set. So from a noble as an exercise as helping catalog and save endangered species, now let's imagine that we want to help create ad copy for our AI team using the Lex Friedman podcast. We want to create ad copy for some ads we want to send to the Lex Friedman podcast. As an AI company, we are specifically interested in creating these ad copies that matches the keywords and questions that Lex he asks in his clips. So we've taken all the Lex Friedman videos and cut it into clips for each question and answer with the experts, and then we've indexed it with an Encord. So we have not only the videos, but also the audio, because a podcast, as we know, contains both the visual and the audio modality. And now we're diving into the multimodal data set. So here on the audio view, we will see a video, sorry, an audio player.
That's true, it's official.
We can play
The
audio, and we can read along in the transcript here below. So we have the question that's being asked and the answer that's coming, in this case, from Andrew Schuberman. Now, I assume that my growth team, they would want to have videos and audio clips that contain only the most relevant. We can't just skip them everything. So let's try and filter this down to a more manageable subset that we can share with them in a CSV file afterwards. The first thing I want to do is I want to make an assumption. The growth team, they're not interested in any files that are shorter than 30 seconds. So I'll change my duration filter to only show me audio files that are above 30 seconds long and the video clips. Secondly, can go to our custom metadata here. I am going to make an assumption that you want to have clips that contain AI-related topics. We can go to our question field. So this is the question over here. We can now type an AI-specific question. Start out here with LLM to see if anyone who's participated in the podcast talked about LLMs. We see here the first one, Jan LeCun. It's fairly obvious what a question on LLMs. We see here again another one.
just for the example, New York to Paris is
Later.
going to start getting into.
And a few more. So this is 38 audio clips. If we want to go and watch the videos themselves, we can click on the video view. We will see a carousel of the given video. So here we can click load all frames. We have a frame sampling rate. And you can see the given video or the given clip where this audio matches. I'm satisfied with these. I want to send these to my team. So I'm going to add these to the collection, and this will be the AI-related clips and audio. We could do the same now for multiple other types of AI. So we could try and go for reinforcement learning, human feedback. Oh, feedback. In this case, we see 3 audio files. One here with Sam Altman, George Hobbs, and one with the CEO of Perplexity. So all files that might be relevant for our growth team when they need to create the copy for this AI project. Okay, next on the list was pothead questions. So they did talk about one of these gimmicks that they want to do. This should not contain any AI, but just more in general. And ahead of this, I ran a simple classifier over this audio set to see if I could figure out which audio files contained any pothead questions. I turned this into a Boolean classifier, so true, false. We can now see the result in this one. I'm going to go down here and find our pothead question classifier, and I'm going to say true. So my model found that there were 8 audio and video clips that contained a pothead question from Lex Friedman. And if we want to find specifically where in the transcript this is mentioned, we can pull up our question field here from before and just search for it. So super simple way of quickly finding information that is relevant for the rest of our team members. And we can now take the video clips and the audio files as before and add them to a collection. So with these collections, we can now take different actions. So you can either create data sets if you want to label your data, you want to train your model. On this case, when I'm working with my growth team, I just want to get a quick CSV. So my growth team, they can reference these later. So this just pulls the CSV. It can also be done using the SDK that I can send to my team right after this call. Here we go. Okay, so we've covered 2 use cases for Index, both structuring and cataloging endangered species and searching and filtering over interesting clips from the Lex Friedman podcast. If we take a step out of our folder here, I can show you what Encord Index looks like from a helicopter perspective. So in Index, you can structure all of your projects or data sets into a folder-based system, similar to what you're familiar with in your S3 bucket or your GCP bucket. And you can dump all of your data in here with your metadata and sort it in the same type of folder-based system. If you want to manage any type of role-based access control, let's say I want to give Eric access to this Lex Friedman podcast that we just did. It's as simple as adding Eric as an admin or a viewer, and he will now have full access to the data within this folder, while the rest of our team, they will not be able to view it or access it. Okay, thank you for listening in. Let's go back to the Q&A.
Thank you, Nico. Very nice demo.
Thank you. So we have some shared questions here that came in ahead of today's call. First one is, I have data at numerous locations. How do I centralize it? Can I use my cloud buckets? I would assume here that numerous locations means that it might be in both some local storage, different cloud buckets, maybe something is in tabular format, maybe something is in different regions. And the question is, how can we centralize all this in one place and actually be able to search it? For the first part, yes, you can centralize it. What you want to do is you want to get it all imported into your cloud buckets first, and then afterwards registered in the Encord platform. So the cloud bucket gives you a safe and secure way to store your data, but it doesn't necessarily give you a way to search, sort, and filter it, or work with it for data training, sorry, for data labeling or model training. So that's where you want to register it in Encord afterwards. And yes, for the Encord platform, as we covered before, you can attach your own cloud bucket. Second one, how do I share actions among other team members? So do you have any access control? I think we just covered this here right at the end. Yes, we do have action control, both in terms of the members that are in the Encord platform. So there's different levels of access based on what entities you need to have access to and what type of collaborator you are, but also on the particular entities within Encord. So now we've talked about folders, we can also talk about projects. You can give role-based access control to the individual people. Anything to add here, Eric?
No, I think this goes to the point around collaboration. You want to make sure that it's as frictionless as possible for other members of the team to get access to the data that they should have access to and not see the data that they shouldn't have access to. And this is very, very difficult to build in an internal system. And we've thought a lot about how to do this properly at scale for big organizations, big and small alike, because collaboration is the name of the game in building good AI systems.
Thank you. And then the last one here, you say scale in the title. How big can it go? I think I'll have to hand that over to you, Eric, first.
Sure. So the scale that we can do now is billions of frames, hundreds of millions of files. We've spent a lot of time investing in the data infrastructure to make sure that it can scale for the different customers that we have and for very, very large AI projects. But we're constantly trying to get to the next level. So we're constantly thinking about how do we get bigger? How do we get even more scale? Because this is really at the forefront of where AI is at the moment. And it will be quantity and quality of data that dictate the best possible models that you can create. So we are looking to get all of the data in the system.
Then we have a question here from the Q&A from Anonymous. What about the LLM project, whose authors found that the models that were trained only on repositories with large stars performed worse than the models that were trained on, I'll assume in this case, all of GitHub, it says all of the data. It's an interesting one. I can give it a go, Eric, and then you can fill in the gaps.
Sure, you can give a stab at it first. I also have some thoughts.
Interesting. I mean, with a lot of these papers we see on performance for new models, we are gonna see that multiple papers are gonna show one side of the coin and another side of the coin. You're always gonna find some that prove it and prove it wrong. And in a lot of these cases, it's always interesting to look at what is the problem that you're trying to solve for. In this case, if it's an LLM that's specialized in coding and it's trained on only the best repositories, it'd be interesting to see what is actually the population of the best repositories and how generalized are those best repositories.
I would say it's even simpler that the quality of the data does not necessarily correlate with the number of stars that a repository has. Just because a repository has a bunch of stars does not mean it's the best code for a model to train in. So if you're curating just on stars, maybe that's the wrong North Star metric in your curation algorithm. You can get a lot of stars just by having a very popular Twitter presence. And I don't think that says anything about the quality of the internal code that you create in your repo.
Interesting. That's completely right. Super. I can see we are at the end now. Now there's one more question here from Align Taboo. Do we need to centralize the data? Why not use a catalog to access the data in situations while leaving ownership to the data source?
That's a great question. And that's exactly how we designed the system. So when we say centralize the data, we don't mean moving the data to a centralized location. It's keeping the data where it is with the permissions that it has, and just essentially doing what the question says is cataloging the data, making sure that you have all of the metadata that's associated with it, any other attributes with which it's useful to query, search, and curate it, and having that be in a centralized source where you can then do access controls. So the data itself doesn't move. The data stays where it is, which is a very strong component of the system, because then it doesn't violate any privacy and security constraints. You don't have ingress, egress costs, things like that. Yeah,
you're essentially registering your data, and we're just accessing a signed URL whenever we need to visualize the data asset for labeling or for visualization. And also here, Align, you can connect multiple buckets, and it can be from multiple providers at the same time. So it's definitely not an issue with Encord. Super. Thank you, everyone, for joining us here today. It's been very exciting to showcase some of the new things at Encord. Sorry, Eric, any final words on your side?
No, we're very excited about Encord Index, about this new wave of AI as well, of really thinking about it from a curation point of how do you select the best data to send to your model in the first place? How do you do this at scale? How do you do this properly? If you want to discuss these things, we're always happy to have a chat around it, to discuss our thoughts, our findings, and to listen to what other people have learned and what other insights that people have. So feel free to reach out to us. And otherwise, thank you for joining the webinar today. I hope you found it useful. And until the next one, we'll be around.
See you.
Bye.